When Ernest Rutherford returned to Cambridge in 1919, he was no longer the unknown colonial scholar from New Zealand who had arrived a quarter century earlier. He returned as the most celebrated experimental physicist in the world. The students knew it, and they sang about it. Behind the fame was a man who cared little for appearances. His office overflowed with papers. His pipe filled the air with smoke. But Rutherford judged every idea by a single standard. Did it produce results? That relentless philosophy would soon transform the Cavendish Laboratory into the birthplace of modern nuclear physics. Rutherford disliked asking for money. He believed great science depended less on expensive equipment and more on imagination. The Cavendish became famous for what researchers jokingly called string and sealing wax science. If a problem could be solved with ingenuity instead of funding, Rutherford expected his students to find a way. Surprisingly often, they did. By 1920, Rutherford had already transformed our understanding of the atom. But one problem refused to disappear. Atomic masses did not make sense. Something seemed to be hiding inside the nucleus. During a prestigious lecture at the Royal Society, Rutherford proposed a remarkable possibility. Perhaps a proton and an electron could combine into a single neutral particle. He had no proof, no experiment, only intuition. But more than a decade before its discovery, Rutherford had begun to glimpse the neutron. Among Rutherford's students, one physicist became captivated by the mystery. James Chadwick, quiet, patient, and relentlessly methodical. While others debated theories, Chadwick focused on evidence. Rutherford believed a neutral particle might exist inside the nucleus. Chadwick wanted to find it. The problem was that a neutron would leave almost no trace of its presence. Detecting it would require years of careful experiments and a great deal of persistence. For years, the neutron remained nothing more than a possibility. Then, in the early 1930s, unexpected clues began appearing across Europe. In Germany, physicists bombarded beryllium with alpha particles and detected a strange, highly penetrating radiation. In France, Irene and Frédéric Joliot-Curie repeated the experiment and observed effects that seemed impossible to explain. Most scientists believed the radiation was an unusually powerful gamma ray. But when James Chadwick examined the results, he noticed something others had missed. The evidence pointed to something entirely different. Something with mass. Something with no electric charge. The hunt for the neutron was about to enter its final stage.